Okay, folks, in this video, we're going to focus on weak base. And again, let's use this concept map to guide us through the calculation of this example. Okay, so blue part is weak base, so we're going to focus on the Kb. Now let's take a look at this question. Calculate the pH and hydronium concentration of 0.250 mole per liter of triethylamine solution. Triethylamine is a weak base. Okay, pKb of triethylamine is 3.25. Now the first step is you have to write down the equilibrium equation for triethylamine. Since this is a base, it's going to accept a proton when you dissolve that in water, okay, to generate the conjugate acid, which is the cation in this case, and hydronium anion. Now, based on this equation, you can start the construction of the IC chart: initial concentration, change, and equilibrium concentration. Initial concentration for triethylamine 0.250. Initial concentration for the two products 0 and 0. Change negative x for triethylamine, and x equivalent of the two products will be generated. So when you express the equilibrium concentration, 0.250 minus x for triethylamine, and the two products equilibrium concentration would be x and x. Now, the second step is, in order to find out the value of x, which is the concentration of the hydroxide, you have to express the Kb. So that equals to, say, the concentration of the conjugate acid and times the concentration of hydroxide over the concentration of the conjugate base, the weak base, triethylamine. And we've already expressed the equilibrium concentrations for 3 species, so what you need to do is just plug them in. X times x on the top and 0.250 at the bottom. 0.250 minus x at the bottom. Okay, when you reach here, you have to think. In order to solve x, you have to know the value of Kb. Here, the question tells you the value of pKb. How do we find out the Kb? So here is the equation that we need. Since pKb equals to negative logarithm of Kb, so once you have the pKb, you can calculate the Kb value. So let me just use this equation, use this base to do the calculation of the Kb. 3.25 pKb value equals to negative logarithm of Kb. How do we get rid of negative logarithm sign and find out the Kb value? First thing is you multiply -1 on the two sides. Okay. So that gives you this equation. And then the next thing that you do is raise the two sides to the exponent position of 10. So 10 is a base. 10 to the negative 3.25 equals to 10 to the logarithm of Kb. Because 10 to the negative Kb equals to Kb. So you just need to do the calculation to find out the value of 10 to the negative 3.5, and that's your Kb value. My calculation gave me 5.62 times 10 to the negative 4. Oops, sorry. It should be negative 4. Okay. Right now, we have Kb, so you can just plug that in and find out the x. So 5.62 times 10 to the negative 4 equals to x squared over 0.250 minus x. And now we can make the assumption about the x. Since the Kb is very small, it's reasonable for us to make the assumption about x. Okay, so we treat x as a very small number. When you have a big number minus a very small number, approximately that would be just the big number itself. So approximately that is x squared over 0.250. So what you need to do next is to find out x. Multiply 0.250 on the two sides, take the square root, and you get your x value. What I got here is x equals to 0.01186 mole per liter. Okay, 3 significant figures. All right, now let's think about the x. Based on our IC chart, x is the concentration of the OH. So when you take the negative logarithm of this one here, you got your pOH value. So pOH value equals to negative logarithm of 0.01186 mole per liter. That gives me 1.92. And one thing I forgot to mention here is you have to validate the assumption. Okay, so let's put it here. This actually would be step 4. Step 3, let's take the ratio between the x and the initial concentration of this weak base. There, 0.250 times 100%. That equals to 4.7. Again, it's less than 5%. So our assumption is good. Okay, so x value here is the concentration of hydroxide. Now you take the negative logarithm of this concentration, you got your pOH value 1.92. Now the pH value would be easy because you can just use 14 minus 1.92. And I got here is 12.08 pH value. Now the last thing that we need to do is the concentration of hydronium, because the pH value equals to negative logarithm of hydronium concentration. So you know the pH value 12.08 equals to negative logarithm of hydronium concentration. Okay, and here in order to get the concentration of this hydronium, you are going to move the negative sign to this side and then raise the two sides to the exponent position of 10. Okay, sort of like we did for when we calculate the Kb value. So my calculation gives me hydronium concentration equals to 10 to the negative 12.08 mole per liter, and that gives me 8.43 times 10 to the negative 13 mole per liter. Okay, so we got it. Another an alternative way to find out the hydronium concentration is, okay, let me just use this space here to demonstrate. you can use the ten to the negative 14 divided by the hydroxide concentration, okay, which is 0.01186, and you should be able to get the same number here. It doesn't matter which way you want to take, okay. You should, as long as you show me the process, show me the answer, and you will solve this problem. Okay, so let me know if you have any questions.